I'm really tickled pink to have my name and Turing's name mentioned in the same sentence. That's a very mind-boggling concept.
Just across the road from the Computer History Museum in Mountain View, California, stands the West Coast office of Microsoft Research. This is the workplace of principal researcher Leslie Lamport, who has been named the 2013 recipient of the prestigious ACM A.M. Turing Award.
The main thing that I think Leslie did was he essentially invented or discovered the field of distributed systems.
Established in 1966, this pinnacle award celebrates the life work of those who have advanced the art of computer science in groundbreaking ways. Often called the Nobel Prize of Computing, the ACM A.M. Turing Award conveys a substantial cash endowment and opens the door to even greater prominence for its accomplished recipients. His work began over 4 decades ago, yet it remains central to the way computers cooperate, avoid errors, and reach consensus.
Looking at distributed systems and concurrent systems, the key player here is Leslie Lamport.
One of Lamport's great works appeared in Communications of the ACM in August of 1974, when he introduced what came to be known as the bakery algorithm. Another notable moment arrived in July of 1978, with a paper in Communications of the ACM that defined time based on causality rather than physical clocks. It's one of the literature's most cited papers.
Most of my important stuff has been in ACM publications, but that's because ACM has published the most important journals in the areas that I've been working in.
Perhaps his most famous work was the introduction of the Paxos algorithm in ACM Transactions on Computer Systems in May of 1998. It describes a way to guarantee the safety of messages passed among multiple players, even when some of those players are unreliable. Paxos wasn't well understood when it first appeared under the title The Part-Time Parliament. But as it gained currency, Lamport spun out numerous variations to cover a wide variety of circumstances and implementations.
Well, Leslie has really, I think it's fair to say, laid the foundations of distributed and fault-tolerant computing. And nowadays, when we have machines with dozens of cores and data centers with hundreds of thousands of computers in them, this is just the way computing's done. And Leslie showed us how to do it reliably.
As a side project, Lamport created LaTeX, now a standard in layout and typesetting wherever mathematical formulas appear. Underlying all of Dr. Lamport's work is an insistence on specifications, using math, logic, and provability to create reliable systems. To serve this goal, he created the temporal logic of actions and the language TLA+, now a standard part of the system designer's toolbox.
My idea basically is that the best language that mankind has developed for stating things clearly and precisely is mathematics. And so the best way to write a specification is using mathematics. Amazingly enough, this is a controversial idea.
Lamport's ideas often shook his colleagues' thinking, but his insistence on rigor and provability won out in the end.
Although I had failed to somehow form a grand theory, what I had done through my wanderings is to create a path. And a lot of people have followed that path and then taken it much further than I ever went. And a lot of people who are a lot smarter than I am. But I did, in my wanderings, create this path that a number of people have followed. So that is something to be proud of.
The Association for Computing Machinery sincerely thanks Leslie Lamport for all he's done and congratulates him on being the 2013 recipient of the ACM A.M. Turing Award. We're pleased to feature his life and work in the June 2014 issue of Communications of the ACM. A banquet in San Francisco celebrates him, along with recipients of this year's other ACM Awards.